Welcome. We will go over study problem 4-1. This is a very simple problem, and so let's first try to grasp what's going on inside this problem. So we're given a company and some figures from the balance sheet. Basically our current assets and current liabilities are provided to us. The firm, however, would like to increase its inventory, naturally, and to do that they will need to borrow from a bank, and that would be in the form of a short-term note. The firm actually has a concern, though. While doing this borrowing, the firm does not want its current ratio to fall below the level of 2.0. And let me remind you that the current ratio is equal to, as a side note, current ratio is equal to current assets divided by current liabilities. So therefore, a bank loan will definitely change this ratio. But first, let's figure out the current assets, the new current assets after inventory has been increased. So the new current assets is equal to previous current assets of $2,145,000 plus an addition of X. Let's call the amount borrowed from the bank as X dollars, and we use all that money to increase the inventory. Well, after the financing, our new current liabilities would also change. It would increase from $858,000 to $858,000 plus X dollars. And that would do it. So now we can go back into our formula for the current ratio. Sorry for that. So that was a typo here. Current ratio here. So that would be equal to our current assets is this figure here that we just made note. In fact, I might need more space, so let me just write this ratio right over here. So we have this new ratio, which is $2,145,000 plus X dollars divided by new current liabilities, which is $858,000 plus X as well. And the firm had a constraint, has a concern, and we don't want that ratio to fall underneath 2.0. So we want to make sure this ratio is well above 2.0 all the time. So that's our target. Okay, so the rest of the problem is just some algebraic computation, and let's quickly do it together. So we have, and I will do it with a separate color here. So the way to solve this inequality would be, first, let's assume there's a one invisible one here in the denominator on the right hand side, and then we can do a cross multiplication. So after the cross multiplication, we would have things multiplied by 1 would not change. So that's our left hand side. That would be greater than or equal to things multiplied by a 2. So 2 times what we have here, 858,000 plus the X dollars. Okay, so in the second step, so we can, the right hand side would adjust, and so let me rewrite the left hand side first. Oops, I'm missing a 0 there. So that should be greater than or equal to, now 2 times 858 would be $1,716,000. And another 0 here, and 2 times X. So we just basically distribute the 2 over the 2 things inside. I will move all the X's onto the right hand side and all the numbers onto the left hand side. Obviously I need to subtract $1,716,000 from $2,145,000, and that should come out to $400 and I would like to say $469,000. I hope I'm not wrong. I will check that calculation at the last step, and then that should be greater than or equal to 2x minus x, which is just x. I have 200 and okay, so 5 minus 6 would be a 9, 4 minus 1, oh, so that should be actually, that's wrong, that should be 429, I believe. So let's make a quick revision here in our calculation. Going back, yes, so that's a 2 here, and that's a 4, just to clarify. Okay, and that's the maximum loan that the bank, that our company should take from that bank. And so long as we borrow an amount less than or equal to 429,000, our current ratio should not fall below its target of 2.0, and that would be all about this problem. And